Let's find the greatest common factor of two numbers. So here are three examples, and we're going to walk through each and every single one of them. The key to finding common factors is actually write the number in its prime factorization. In other words, 36 is 6 times 6. So perhaps off to the side here, some of you may have learned factor trees. If you write 6 times 6, then you write 2 times 3 times 2 times 3. And the prime factorization is usually at the bottom there. It sort of looks like a tree of some sort. Okay, you could do the same thing for 44. 44 would be what? 4 times 11. And then 4 is broken up as 2 times 2. And then 11, we could just bring that down. Once again, it still looks like a tree. And so there's the trunk, there's a tree. So we call these factor trees. It looks like the presents are at the bottom of the tree during Christmas. Okay, so what do we do with that? Well, we could stack them together. So we could say 36 is equal to 2 times 2 times 3 times 3. And then 44 is equal to 2 times 2 times 11. And whatever they have in common is going to be the greatest common factor. Okay, so in this case, they have two 2's in common, and we multiply them together. And so the GCF of what? 36 and 44 is simply 4, or 2 times 2. How about 28? 28 is equal to what? 4 times 7. So that would be 2 times 2 times 7. And 49 is what? Is 7 times 7. So in this case, what do they have in common? They only have these 7's in common. So the GCF of 28 and 49 is 7. Okay. How about the GCF of 12 and 48? 12, remember, is 2 times 2 times 3. 2 times 2 times 3. How about 48? Well, 48 is 6 times 8, right? So you might want to do the tree. And notice the presents are at the bottom again. Let's draw a tree trunk. Well, this is 2 times 2 times 2 times 2, and then finally times 3. So this time, what do they have in common? And we want the greatest amount of common factors. So we have 2 times 2 in common, and then we also have what? Times 3 in common. So this time the GCF of 12 and 48 is 2 times 2 times 3, which is 12.